Let's now take up with the next chemical reaction, and that is dehydration of alcohol. Now what is dehydration? Dehydration is removal of water. It's that simple. If you can see this representative example, we have this alcohol wherein I just have to remove this H and that of OH, which happens in presence of an acid at a slightly raised temperature, and what we obtain is the removal of this water is going to create formation of another bond between carbon and carbon, and thus it will give us alkene as our product. So basically what happens is that alcohol at a higher temperature of around 443 Kelvin in presence of a suitable acid over here, which is acting as a catalyst, goes to give you alkene as your product with water as a byproduct, because it's a dehydration. So removal of water is taking place. This is a very simple example which we have taken. It's a primary alcohol. Let's take a case of a secondary alcohol. In the case of a secondary alcohol, similar way, you have a removal OH and that of a hydrogen. This reaction takes place at comparatively lesser temperature than that of a primary alcohol. It's around 440 Kelvin, and a comparatively a milder acid is used over here, that is 85% H3PO4 phosphoric acid, and what we have is a formation of a alkene taking place with water as a byproduct. I have a tertiary alcohol, and this tertiary alcohol will react at 358 kelvins, and just a use of 20% phosphoric acid is enough for it to give you alkene as your product. Now we can understand over here that as we move on from a primary alcohol to that of a tertiary alcohol, the conditions required go on becoming, they go on decreasing, or they are mild down. This is because the reactivity of a tertiary alcohol to undergo dehydration is more as compared to that of a primary alcohol. We can understand this by knowing the mechanism of the reaction. So let us study the mechanism of this particular reaction. Now when it comes to mechanism of this reaction, know that we are taking an example of a primary alcohol to understand this. It's very simple. The reaction occurs in 3 steps. First one is a protonation. This protonation occurs very fast. You have a use of an acid in the reaction. So oxygen, because it has lone pair of electrons over here, it goes to attack the hydrogen ion, abstracts the hydrogen, and thus it goes to form a protonated alcohol. This is called as a protonated alcohol. This protonated alcohol further, it goes to, your carbon goes to give out this water molecule. This is a protonated alcohol. Now it can't retain this positive charge, hence what it does is that it goes to give out this particular water molecule. This is comparatively a slow reaction. When the water molecule goes out, it goes with its electron, and hence it leaves a positive charge on this particular carbon atom. So thus giving you a carbocation. This carbocation further, in this particular carbocation which is obtained over here, the hydrogen here leaves its electron, goes as a hydrogen ion. So there is deprotonation which is taking place over here, giving you your product. So this is the alkene which is obtained as the product. So from ethanol we obtain ethene as your product. From this it is clear that the first steps involves protonation, the second step involves removal of a water molecule, and the third step involves deprotonation. So it's simple: protonation, removal of water molecule, and then deprotonation in order to obtain alkene as your product. What we understand also over here, and That can be a reason to understand why tertiary alcohols have more tendency to undergo the dehydration, or the ease of tertiary alcohol undergoing dehydration is more. It's because of the formation of this carbocation. Okay, tertiary carbocation is more stable as compared to that to secondary, as compared to that of primary. So therefore, in this particular case, the ease at which the product will be formed will be it will be better in the case of a tertiary than that of in the case of secondary, than that of in the case of primary.